Hey, good morning, ladies and gentlemen. How are y'all doing today? All right. All right, so today and Friday we begin uh, our review for the final exam. Um, Now, basically, you can bring anything to the table. Are there questions from the uh, review that you have? Are there questions over homework? Have you looked back at the exams? Are there questions from those? Anything can be brought to the table, and we can talk about it. As a reminder, our final exam is going to be next Wednesday from 8 to 10. Um, so we'll get started at 8 o'clock on Wednesday of next week. So, the only thing as far as assignments for this week that will be due by Sunday um, is assignment 26, Kramer's Rule. So let's go ahead and get started. I'll go ahead and put this back up on the board real quickly. But from the review, the last three problems, 71, 72, and 73, you can omit. Those have to do with partial fraction decomposition, and then also the binomial theorem. We did not cover that material, so we're good there. So let's open up the floor. As I stated before, this is your time to ask your questions. Again, they can come from anything that you want, so as I like to say, the floor is yours. What do we need to go over?
Can we go over number 15 on assignment 26?
Number 15 on assignment 26, sure. Let me get there real quick. Assignment 26. Number 15. Alright, so the logarithmic equation?
Yes, sir.
Okay. So from assignment 26, we have problem number 15. Log base 3 of x plus the log base 3 of an x plus 8 is equal to 2. Alright, so anytime that we're dealing with a logarithmic equation, one of the first things I look for is any opportunity to condense logarithms. We'd rather deal with one logarithm rather than two, so I can condense, that's not how you spell condense, these two logarithms, and because of the plus sign, we're going to use the product rule. So this becomes the log base 3 of x times x plus 8 is equal to 2. Which we can continue to make this a little bit more simplified. I'm going to distribute that x, so we get x squared plus 8x. equals 2. Now, the next thing that I'm going to do is I'm going to rewrite in the exponential form using our relationship that says for y equal to the log base b of x, this is equivalent to b to the y is equal to x. So that tells us then that the exponential form of this logarithmic equation is 3 to the second power is equal to x squared plus 8x, which we get 9 is equal to x squared plus 8x, which now this is a quadratic equation because of the x squared. How do we solve quadratic equations? We set them equal to 0, so I'm going to subtract that 9 on both sides, set it equal to 0. And now we want to solve this quadratic equation. Well, things are going to be, this is going to be able to be solved by factoring. You could use the quadratic formula, but I think factoring is quicker. So we have x factors of 9 that add up to negative 9 that add up to positive 8. How about a positive 9 and a negative 1? Which then means after you set each factor equal to 0, you get x is equal to negative 9 and x is equal to 1. But make sure that you check your solutions. And here's the key thing, especially dealing with logarithms. You cannot take the logarithm of a negative number. If you try it in your calculator, you're going to get an error. The domain of logarithms is only things that are greater than 0. So immediately when I try to plug negative 9 back up here, I get the log of a negative number. Can't do it. So immediately I'm just going to go through and say, well, it can't be negative 9. That leaves me just with 1. I'll leave it to you to go through and check this, but that's our one and only solution. Alright, so does that make sense how to solve this logarithmic equation?
Yes, sir.
Good. Alright, what else can we look at?
On the review, can we do number 31?
31 from the review. From the review. Problem number 31. Use the given conditions to write an equation for each line in slope-intercept form. So we want the horizontal line through the point 7, 2. Alright, so quick review. A horizontal line is of the form y is equal to b. So on a coordinate plane, if this is b along the y-axis, we have a horizontal line through that. So whatever, and we can see that this is horizontal, and we name that equation y equal to b. A vertical line has the form x equal to a. So again, on a coordinate plane, where we have the x-axis and the y-axis, any point along the x-axis, let's call it A, we have the vertical line. So, going back to this problem, what is the horizontal line through 7, 2? Well, if we need, I'm a visual person, so if I just plot this real quickly on a coordinate plane, 7, 2 means we go to 7 on the x-axis, 2 on the y-axis. There's the point, and it's a horizontal line through that point. So there's the equation y is equal to 2. Now, something about this, if you look at the instructions, to write the equation for each line in the slope-intercept form, well, just as again as another quick review, slope-intercept form is y is equal to mx plus b, where m is equal to your slope and b is your y-intercept. Well, this fits the slope-intercept form because I could rewrite this as y is equal to 0x plus 2 to remind ourselves that the slope is 0. But we wouldn't write this as an answer, but this would be, if you want to get really technical, this could be a representation of the slope-intercept form because this would tell us that the slope is 0 and the y-intercept is 2. Does that make sense?
Yes, thank you.
You're welcome. Alright, what else can we look at?
Can we do number 48?
From the review?
Yes.
Alright, 48. Okay, so we have x to the fourth plus a 6x to the third plus a 5x squared minus 24x minus 36. And, if we look at part B, we want to find all the zeros, all the roots of this function. So that's going to start off by finding those possible rational zeros. That's part A. So recall that to find the possible rational zeros, we look at the factors of the constant divided by the factors of the leading coefficients. So in this particular case, that's going to be the factors of negative 36 over the factors of 1. And I like it when I'm just dealing with the factors of 1 because then I can say that those possible rational zeros are factors of 36. I got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6. And because 6 times 6 is 36, now I can just start working, going backwards. 4 times 9 is 36. 3 times 12 is 36. 2 times 18 is 36. And 1 times 36 is 36. Alright. So now we want to go through the synthetic division process. So I'm just going to get it started here. Let's test x equal to 1. So this is a good opportunity to recall synthetic division. We want to list out the coefficients: 1, 6, 5, negative 24, negative 36. And we're going to go and play the synthetic division game. Bring down the 1. Then we multiply. 1 times 1 is 1. Add. That 6 plus 1 is 7. 1 times 7 is 7. Add, we get 12. 1 times 12 is 12. Add, we get negative 12. And I don't think we're going to get there. Remember, we're looking for a remainder of 0. Now, I don't want to spend all day here trying to go through and do this because I'm looking at the answer key, and if you're looking at the answer key, you can see that x equal to -1 doesn't work. Alright, I mean, you can try it for yourself. It's not going to work, but as soon as we get into x equals 2, 1, 6, 5, -24, -36. Let's see what happens here. Bring down the 1. Multiply. Add. Multiply. Add. Multiply. Add. Alright, so -24 plus 42. Oh, we gotta do some math. 18. And then multiply by 2, that's going to be 36, and there we get the 0. So, by this, we know that x equal to 2 is a 0 of the function. Now, remember what this means. These coefficients down here mean that we now have the polynomial x to the third plus 8x squared plus a 21x plus 18. Now, we want to continue the process of synthetic division. So we're looking for when does this equal 0. Now, again, to save time, I'm going to go straight to the next possible 0, x equals -2. Normally, I would try x equal to a second time because you never know if 2 is also a 0 of this polynomial. But for the sake of time, let's just move on to x equals -2. 1, 8, 21, 18. So we begin the process of synthetic division. Hold on just a second. Alright, sorry about that. Here we go. Bring down the 1. Multiply by -2. Add. Multiply by -2. And 21 minus 12 is 9. Multiply by -2. -18. There we get our 0. So, since we have 0 as a remainder, there's a second 0 of this function. So from this we have that we have the trinomial x squared plus 6x plus 9 is equal to 0. Now as soon as I get into a trinomial, I'm going to abandon synthetic division and I'm just going to go to solving this. How can we solve this quadratic equation? I would factors of 9 to add it to 6. How about x plus 3 times x plus 3 equals 0, which then means x is equal to -3. There's our third 0, but this has a multiplicity of 2. Now, remember, what does it mean to have a multiplicity of 2? That means that the graph is going to bounce at x equal to -3. So let's pull all this information together. We have zeros at 2, -2, -3. So I'm going to come over here to my graph. By the way, you will have coordinate planes to graph on, but I'm not going to, it's going to be like the previous coordinate planes, where, yeah, there's some dotted lines like this, but you don't have to use these grid lines to define 1, 2, and 3. You can just put them wherever you want. But let's do this. Let's do it on the grid line since I already have it drawn out. There's -3, -2, +2. Now, we have to decide what this graph is doing. Now, there's a couple of ways to do this. You could plot points. You could say, well, what happens if the graph, if I plug in -4? Do I get a positive value or a negative value? To help you determine what the graph is doing over here. Or, if you recall, when we talk about end behavior, because we have x to the 4th, that's our leading coefficient, because the 4 is even, and the 1 that we have right there, that 1 is positive. So even functions have the same end behavior. So that means it's going to rise both left and right, or it's going to fall both left and right, because 1 is positive. Pulling all this information together, it means it's going to rise on the left and right. Same end behavior, 1 is positive. So what does this graph do? Now, remember, at -3, it's going to bounce. So if it's rising like this, that means it's going to bounce at 3. Now, what comes up must come down, and we have to cross through it too, so we're going to cross. By the way, another thing that is helpful, that -36, that is our y-intercept. So I'm just going to put -36 right here. There's my y-intercept, and what does it have to do? It has to come back up. And there's the sketch of the graph. Now, does this sketch exactly match what you see on the answer key? No. Technically, this graph would probably come further down like this before it came up. But I'm not going to knock off points on that. What I'm looking for is this. Do you have the correct end behavior? Do you have the correct zeros, or are the zeros the same zeros that you have over here on the in your work? And do you have the correct behavior at each zero? Meaning, is the graph bouncing at -3, crossing at -2, and crossing at +2? Alright, so that question. Does that make sense?
Yes, sir. Thank you.
You're very welcome. Alright, what else can we look at?
Can we look at number 50?
Did you say 50 or 15?
50. 50.
50. Alright. Looks like we are dealing with a rational function. Number 50. So in the find the horizontal and vertical asymptotes, find the additional points, sketch the graph. Alright, here we go. We have the function f of x is equal to x plus 2 over x squared plus 3x minus 4. Now, for just notational purposes, we're going to call the top p of x and the bottom q of x. So, I'm just going to go through and this is in no particular order. The first thing I'm going to find are my vertical um, asymptotes. How do you find those? We need to solve q of x equal to 0. We set our denominator equal to 0 and solve. So I have x squared plus 3x minus 4 equals 0. This is a trinomial that we can factor, so this becomes factors of 4, negative 4 that add to 3. How about a positive 4 and a negative 1? Which then means x is equal to negative 4 and x is equal to a positive 1. These are my vertical asymptotes. When we talk about vertical asymptotes, we want to express as equations. Express as an equation. Don't just tell me negative 4, 1. Tell me x equals negative 4. Tell me x is equal to 1. The next thing that we want to find is that horizontal asymptote. Now, we were dealing with this type of question a couple of days ago in another class. And the question here is this. What is f of x approaching as x goes to plus or minus infinity? What is the function doing as my x's get, let's just say for what it is, really large? Really big positive numbers, really big negative numbers. Now, if you just take your calculator out and do this, if you start plugging in values for x, the bottom is going to get much bigger. It's going to get bigger quicker than the top does. As soon as you start doing 100 squared, 100 squared, now you're talking about 10,000. Then when you go to 1,000 squared, you got 1,000 up here and then 1,000,000 down here. So you have a relatively, you have a small number over a big number. And anytime that you take a small number and a big number, as the difference between a small number and big number gets bigger and bigger and bigger, your answer gets closer and closer to 0. Now, we also did this test where we took the degree of the numerator and the degree of the denominator. Since the degree of the numerator is less than the degree of the denominator, we made the conclusion that y equal to 0 is our horizontal asymptote. You can go through and read through that section again about what makes a horizontal asymptote, but there it is. What else do we need? It said additional points, right? So maybe an additional point is the x-intercept, if there are any. How do you find an x-intercept? We need to solve p of x equal to 0. So that's going to be our numerator. So if I set x plus 2 equal to 0, that means that x is equal to negative 2. So as an intercept, this would be negative 2, 0. There's my x-intercept. What else might we need? D would be possibly a y-intercept, again, if there is one. How do you find a y-intercept? We need to evaluate f at 0. We want to plug 0 into our original function. So if I plug 0 into my original function, anything that has an x in it becomes 0. So you end up with a 2 over negative 4, which is equal to a negative 1/2. So we have a y-intercept at 0, negative 1/2. Alright, so let's start putting this information together. We have vertical asymptotes at negative 4 and 1. So let's just put it down here. So I'm just going to call this is -4, and then this is 1. Now, I'm going to use a dotted line, different color. If you're just using pencil on your exam, just make sure that you use a dotted line. And then we have a y horizontal asymptote at 0. I have an x-intercept at -2 and a y-intercept at -1/2. And we want to start graphing. Now, I can tell you right now what's happening in the middle. Notice that this x-intercept has a multiplicity of 1. It's not a repeated 0. So, since it has a multiplicity of 1, since 1 is odd, that means it's going to cross through the x-axis. So what does that mean? It can't bounce. So, if we connect these 2 points right there, what does the graph have to do? Well, it can't bounce, so what does it have to do? It has to come up. And then what does it have to do over here? Again, this is the only x-intercept. It's the only x-intercept. So what does the graph have to do? It has to go down. Alright, so this isn't very, there we go, a little bit better. A little bit better. Now, the next question that you have to ask yourself is, what is the graph doing over here and over here? Well, I'm just going to do a quick test value. F at -10. Now, all I care about is whether or not the function is positive or negative. I don't actually care about the numerical value. So, if I plug in -10, -10 plus 2, that's going to be a negative. Now, -10 squared is going to be 100. Yeah, minus 30, minus 4, that's still going to be positive. So you have a negative over a positive, which is negative. So what does that tell me about my graph? That tells me that the graph is below the x-axis. So my graph looks like this. And then I'm going to do the same type of work for f at +10. +10 is some value over here. So again, take a look at my function. If I plug in 10, 10 plus 2 is 12, great. All I care about is that it's positive. If I plug in 10 down here, it's also going to be positive. So a positive over a positive is positive. So we can sketch the graph that looks like this. And there's the sketch of the graph. So what was required of us for this problem? We certainly had to find the asymptotes. Now, I've already made the test. And I had declared on a problem like this that there is an A, B, I can't remember if it's C and D or just C, but A and B say to find the vertical asymptote, find the horizontal asymptote, and C and D, or if it's just C, say to find the intercepts. So I'm going to be looking for this type of work that shows me that you've gone through and found the asymptotes, both vertical and horizontal, the intercepts, and then I'm going to be looking at your graph. First of all, are you graphing what you stated up here? And then second of all, is your graph behaving appropriately? Meaning, back here, is your graph below the x-axis? Is your graph above the x-axis? I'm going to be looking for that bit of information. Is the graph going up and then down, that sort of thing? Of course, that all depends on the particular problem. Alright, so does this make sense for problem number, whatever that was, 50?
Yes, thank you.
You're very welcome. Alright, what else can we look at?
So I have a question over exam 3.
Okay. Let me, is it Just a question over a problem?
Yes.
Alright, let me see. Let me pull up exam 3. Okay, what problem from exam 3 are we looking at?
30.
No, that's quiz 3. Um, okay, yes. You want to just go over it?
Yes, please. I don't know how to do it.
Okay. So, this is coming from exam 3, problem number 30, and we have the log of 4x minus the log of 2 is equal to the log of 3 plus the log of 6. So, we've done a logarithmic equation already. We're going to do, this is going to behave much in the same way. The first thing I want to do is I want to condense the logarithms. I'd rather have one logarithm on each side of the equation rather than two. Now, I remember grading this problem, and some of us went ahead and moved the log of 2 over to the other side. I mean, that's fine. I'm not going to do that. What I'm going to do is I'm going to condense these two logarithms. Now, this has a minus sign. So what rule do we use? We use the quotient rule. And this has a plus sign, so we're going to use the product rule. So the quotient rule says that we now have the log of 4x over 2 is equal to the log of 3 times 6. Now the nice thing about this is I can go ahead and simplify. So this becomes the log of 2x is equal to the log of 18. Now, there's a nice little property that we could use here. So we have a logarithm equal to a logarithm. Alright. If the log base b of a is equal to the log base b of capital B, then a must be equal to b. It's this idea that since these both have the same log base, the base is 10, this is a common logarithm, since we're taking the log, same base on both sides of the equation, the insides of these logarithms have to be equal to each other. This declares then that 2x has to be equal to 18. It has to be. And now we can solve this. Alright, how do we solve this? We divide both sides by 2 and we get x is equal to 9. And there's our answer.
Oh, okay, that makes sense. Thank you.
You're very welcome. Alright, what else can we look at?
Can we do number 43 on the review?
Yes, ma'am. So, from the review, problem number 43. So this begins, first of all, with, we are given that f of x is equal to a 1/3 x minus 3, and g of x is equal to a 3x plus 1. This is what we're given, and we are told to find g of f of x. Alright, so this is called the composition of functions. So if you want some more examples, you can always just Google composition of functions. But this notation, the way we read this notation is we interpret this as the function g, and we're plugging in f of x. I'm going to write this out, we're going to plug in f of x into g of x. So I'm going to be looking at the function g of x. G of x is 3x plus 1, and I'm going to replace this x with f of x. So g of f of x is equal to 3 times f of x plus 1. That's what this is. This is saying 3 times x plus 1, so 3 times f of x plus 1. Now this is where we start substituting. What is f of x? F of x is 1/3 x minus 3. Then we're going to add, don't forget that plus 1. Alright, so what do we get? 1/3, 3 times 1/3. The 3's cancel out, that just leaves you with the x. 3 times negative 3 is a negative 9. Don't forget the plus 1. So that means x is equal, that means that we get x, negative 9 plus 1 is a negative 8. And that is g of f of x. Now, first question, does that make sense?
Yes, thank you.
Alright, I want to do one thing really quickly since we're talking about this. Suppose that I was told to find g of f at 2. Two ways to do this. Number one, you could find out what g of f is. Now, we know that g of f, since we've already done the work, is x minus 8. So that means that g of f at 2 is equal to 2 minus 8, which is going to be equal to a negative 6. All I did was I just plugged in 2 into g of f. We got negative 6. One other way to do this. G of f at 2 is the same thing as the function g, but we're going to plug in f at 2. Alright, so to do this, the first thing I got to do is I got to find f at 2. So f at 2, we're going to plug in 2 into this function, so that's going to be 1/3 times 2 minus 3. Maybe I should have picked a better number, but we're going to go with it. So this is going to be equal to 2/3. I'm going to rewrite 3 as 9/3. So that's going to be a negative 7/3. So this is, f at 2 is the negative 7/3. So that means that I'm now going to do g at negative 7/3. Alright, so what is g again? G is 3x plus 1. So I need some more room over here. That's going to be 3 times a negative 7/3 plus 1. So the 3's cancel out, so that leaves you with negative 7 plus 1, which is equal to a negative 6. Oh, it's the exact same thing. Now, I bring this up because there may be a question on the exam that says to find something like g of f at 2, and I want to tell you that you have two options to do this. You can either first of all find g of f and then plug in 2, or you can do what I did here. You can do f at 2 first. That gives you, in this case, the negative 7/3, and then plug in the negative 7/3 back into g, and then evaluate, and you're going to get the same answer. All right. Hey, we got about 5 more minutes. Can we get another problem done?
Say 60 with Kramer's rule. Can you do 60 using Kramer's rule?
Do you say 60
Yes.
using
Yes.
Kramer's rule?
Yes.
Okay. We may have enough time to do this. Let's see what happens. 60. So we have the system x plus y is equal to 1, and then x minus 2y is equal to negative 8. So there's my system. So in the augmented matrix, I'm going to list this off by columns. We got 1, 1, 1, negative 2 equals 1, negative 8. So the first thing I need to do is I need to find D, which is going to be the determinant of our coefficient matrix. Alright, so here's my little shorthand, because I don't want to switch colors. 1 times negative 2 is a negative 2 minus 1 times 1 is 1. So negative 2 minus 1 is equal to a negative 3. So that is D. Then dx, we replace the column of our x's with our constants, so that's going to be 1, negative 8, 1, negative 2. So 1 times negative 2 is again a negative 2 minus a negative 8. So that's the same thing as 2 plus 8, which is equal to 6. And then dy.
Your conference is scheduled to end in 2 minutes.
Thank you. We can finish this. Dy, replace your y's with your constants. So you have 1, 1, 1, negative 8. So 1 times negative 8 is a negative 8 minus 1 times 1 is 1. So that becomes a negative 9. So then, recall that x is equal to dx over d, and y is equal to dy over d. So we have 6 over negative 3, and then negative 9 over negative 3, so that becomes a negative 2, positive 3, so that means our solution is negative 2, negative 3. Or excuse me, negative 2, positive 3. Does that make sense?
Yes, sir. Thank you.
You're welcome. All right. So we're out of time for today's class. So we will continue our review process on Monday. Now, this session is being recorded, my 9 o'clock and 10 o'clock class. So you may want to just, if you're going to go back and watch the videos, you may want to see what we tackled in the 10 o'clock class. once that gets posted, you may want to take a look at the 10 o'clock class video and see, hey, what problems did I cover in there? Because you may
Your
have
conference is
questions
now
there
over.
or whatever.
Goodbye.
I'll see y'all on Friday. Take care.
Bye, you too.
Bye.